let's graph this equation. Y equals 2 tan x plus pi. So, let's get started with some given x values. You can see in tangent functions, your given x values start with 0, pi divided by 4, pi divided by 2, 3 pi divided by 4, and pi. Along with that, you're also given a set of tangent values, which is 0, 1, undefined, -1, and 0. So, let's figure out how this equation changes, essentially, from its differential equation. One thing that I do want to note before I go on, because I made this mistake last time when I was recording, this area you can see where I have this as undefined. In this tangent box, what that essentially means is that's going to be our asymptote whenever we actually graph this equation, which means that the graph itself will never touch this point. And you'll see that a little bit later. So let's find the y values. So the y value itself is affected by the a value, which is 2. I already have it circled. And then any number that would come outside of this box, which I don't have any. So you can take the default set of tangent numbers and then apply that to. So instead of 0, 1, undefined, -1, and 0, you're then given 0, 2, undefined, -2, and 0. Now those are your y values, but your set of tangent values, that's really used just to define where your asymptote is. Alright, so let's find the x values. I obviously already listed out the given x values, so how do we find an x value from this equation? So, whenever you're trying to find it, you're supposed to take out any number, your b number, which should go before that x, and there's none there. So then the final step for that is by subtracting h. H is pi. So what you want to do is you want to subtract pi from your given set of x numbers, 0, pi divided by 4, so on. So I have all this math here that you can see. So 0 minus pi equals -pi. And there are the rest of these calculations. Once you have that, you also have your x values. So, see what this would look like on a graph. Yep, here's what it looks like. That undefined, or the asymptote right there,